Welcome to the lectures on deep reinforcement learning. In this video, we will introduce deep Q-learning. So now we have the essential ingredients. We can take whatever input. The states are represented by this neural network. The neural network has many layers. In the famous paper of Ni et al., they trained neural networks always with the same architecture to play 49 different Atari video games. The input were just 4 frames from the video. The network was a convolutional neural network. The reward was the increase of the score that's indicated on the screen when you play. And then this neural network was trained with one of these error functions. Previously, I discussed the error function for SAXA. Now this is the error function of Q-learning. The difference is that we have an additional maximization, max over A prime, max over the next possible actions. And well, the output are the Q values. If you want to choose the next action, you could choose the softmax function, but you could also use epsilon greedy or something else. So deep Q-learning is just normal Q-learning with a continuous or high-dimensional state space, and you represent this continuous high-dimensional state space in the input of the neural network. The neural network transforms this to a more compressed representation close to the output. And then at the output, we have Q values that are represented by the output units of the deep artificial neural networks. And then our action choice, the policy, depends on Q values, typically a softmax or epsilon greedy. For training, we use a semi-gradient on an error function, either the SAXA error function or the Q-learning error function. The Q-learning is off policy, SAXA is on policy. Now, Ni et al. Used further tricks. They further stabilized the target values. Remember, what is the target? The target is this. They further stabilized these target values by representing it as a separate network, and the Q values, the momentary Q values, were represented by a first network that updated its weights more rapidly. The second target network got updated only from time to time. And another trick was the offline updates. So they remembered in some buffer state actions, following state, following action, quadruplets. And then they replayed this from several times in the background of policy so as to adjust the Q values while not really taking an action in the game. And all of the deep reinforcement learning is very well covered in the book of Sutton and Bartow on reinforcement learning. It would be in particular chapter 13 and 16.